Hello everyone, welcome back to my channel. I am Kedar. I am an architect and a designer, and on this channel I talk about design, architecture, parametric design and generative AI. And in terms of Gen AI, in the last 2 weeks we have seen a lot of models that have been released, from Nano Banana Pro, Flux 2.0, Z-Image Turbo, OIS Image and C-Dream 4.5. And while all of these models are really great, I personally felt like Nano Banana Pro, Flux and C-Dream were an incremental update to the previous model. Yes, they now can generate more better images, have more semantic understanding of the image, but this particular model, which was Z-Image Turbo, caught my attention because the images generated by this model were really photorealistic, and I started to wonder why is this model generating such high realistic images, and the answer was in the research paper. So I read the paper, and here they clearly mention that to train the Z-Image model, they have purely used real world data without any AI images in the training process, and that is why the Z-Image Turbo model is able to generate such high photorealistic images, and this is the model that I want to talk about in this video. So while I'll be focusing on Z-Image Turbo in this particular video, the Z-Image family has two more models, which is going to be the Z-Image base version and for image editing the Z-Image Edit model. But these two have not been released yet. But in the paper that I'll be showing you all, which is called Z-Image, an efficient image generation foundation model with single stream diffusion transformer, this talks about the training process for all of these three models, that is the base version, the editing version of the model and the turbo version of the model. Okay, so first let's see the paper and then we'll see how to implement this model inside of ComfyUI. So in the abstract, in the first paragraph, they say that while we have good models that could be Qwen, Hunnion, Flux, they're trained on around 20 to 80 billion parameters. That is why they're not able to use on consumer grade CPUs and GPUs. If you have recently seen the Flux 2 model, it is around 64 GB and it's absolutely insane. And yes, while we do have the GGUF version of this model, we know that whenever we use any GGUF version of the model, the quality is going to drop. To address this, the Z-Image model is only trained on 6 billion parameters with a process called S3DIT, which we will see later on. Then later they say, the Z-Image exhibit exceptional capabilities in photorealistic image generation because they're only using real-world data, and bilingual text rendering that's going to be English and Chinese, delivering results that rival top-tier commercial models, thereby demonstrating that state-of-the-art results are achievable with significantly reduced computational overhead. And this is kind of similar to DeepSeek when it came in. It was a rival model to ChatGPT and it performed really well without using so much of computational resources. So this is similar to that. Okay. Now later in the paper, they talk about the contents of this particular paper, and it is an exhaustive paper. I would recommend you to read at least first 5-10 pages to understand the process of how this is happening. But if I make a video talking about its entire 48 pages, only the paper will take around an hour. So what I'm going to focus only on point number 2, 3 and 4 and not upon performance evaluation because that is a little bit subjective. So the way I've divided the training process into these 6 stages. The first stage is going to be data and how it is curated. The next one is going to be how they're adding captions to this image. The next one is going to be how the model is trained, what is the architecture, the objective. The next is how the turbo model is trained. The next is RLHF, which is how they're improving this model by human feedback. And lastly, some final touches with prompt enhancer. Okay, now let's see all of these 6 stages. The first stage is going to be data infrastructure, which they say, to this end, an ideal data system must be strictly curated to be conceptually broad, yet non-redundant, exhibit robust multilingual text-image alignment, and crucially be structured for dynamic curriculum learning, ensuring that the data composition evolves to match the model's training stages. So basically what they're saying is, depending upon the multimodality of the model, you need to have those images. For example, in this case, they're going to have also Z-Image Edit. So they also need to have the before and after of the image. If you're just training the model for image generation, then only have the captions and the images. So that's what it means. Okay. And now let's see how data is gathered and curated in this stage. So the first stage is going to be gathering this massive uncurated data, for which they are going to add a p-hash based on the resolution and the file size. Now this p-hash is kind of like a visual fingerprint to have the first stage of deduplication, which basically means removing duplicated images. Then you have a data filtration process where you remove compressed images, degraded images based on watermark, blurriness, how much noise that image has, color cast, if the images are plain or blank, and if the images have text which is unreadable. readable. So that is the filtration process. Now the next part is really interesting. They have something called as AIGC content detection, which is following the finding of image Gen 3. We trained a dedicated classifier to detect and filter out AI generated content. This step is crucial for preventing degradation in the model's output quality and physical realism. And this is the key concept of this particular model. To retain the realism, they're only using real world images. And this is really amazing. When I read and understood this, I was like, yes, it all makes sense. It all makes sense why this model is really good. Okay. Now the next stage is going to be deduplication plus clustering. Now in this stage, they're going to cluster similar images. For example, let's say same type of cat come in one particular cluster. You only keep the best one. Whereas let's say there are certain cluster where, for example, let's say parametric skin, where you have 10 images and all of them are horrible. In this case, they are going to add external images so that you have a balanced data. Okay. After that, they're going to add world knowledge. Now, why are they doing this? Because this model is only 6 billion parameter. They don't want to lose out on any trending concepts. To do this, they're going to generate a topological graph, and to do that, they're going to use data from Wikipedia, okay, because Wikipedia have all of the concepts. The first step is they're going to remove low use or ambiguous concepts, because it's Wikipedia, right? Anybody can create any content on Wikipedia and say this is good. Then they are going to add missing concept from internal data. Now, because it is trained by Alibaba Group, some concept which they want to be there in the model, they are going to add on top of it. Okay, once all of these concepts have been added, they're going to again group similar concept based on a taxonomy. So for example, cats come under animal, that come under nature. Okay, now to these clusters, they're going to add weight. For example, let's say we have a huge cluster of cats, so the weight is going to be higher versus some other concepts, and that is how they can add trending concept based on the weights. Okay, now let's see the next step. The next step is they're going to add some rare concept. For instance, they give a really nice example in this paper. They talk about a dish called squirrel fish. Now AI understands this as squirrel and a fish, right? And that is why the first image is of a squirrel. This is not what they want. And to curate this, they're going to add labeling. They're going to remove duplicates and remove low quality. And that's how they're going to add rare concepts. So finally AI understands that, okay, squirrel fish is a dish and not squirrel and fish. And the next step is going to be human fixes some mistake, because there will be some mistakes, right? Because the image has to add a caption and they have a scoring system. Now to check if the scoring is correct, humans and AI are going to verify this together and then correct if the scoring is wrong. So this is the last step of data curation process. Now for image editing processes, they're going to do 3 stages. First, they're going to have editing pair of before and after, because that's how AI will train. Because let's say if my hand goes from here to here, so AI needs to know what is the before and the after. Then what was interesting is they are going to take scenes from video, because videos are going to be coherent, right? You have a previous step and you have an after step. So they get multiple permutations of what editing is happening. And lastly, they're also going to take text rendering system. So this is the data curated for editing images. Okay, now let's see how these images are capped, because before going in the training set, all of these images have to be captioned, right? Now to do this, they're creating in-house captioner called Z captioner. Of course, it's obvious. The first step is going to be captioning all of these images based on OCR, which basically is optical character recognition, which is basically like an engine that understands, okay, this is mountain, this is lake, this is human, this is microphone, and so on and so forth. Okay. After that, they're going to add 5 level of captioning to it, which is long, medium, short, tags, and simulated user prompt. In all of this, what was interesting is this simulated user prompt, because it mimics how we prompt. For example, generally when I go to Midjourney, I just type architecture. Now it has to do something with architecture, right? Now what is this architecture? Is it medieval? Is it Gothic? Is it Baroque? Is it parametric? It has to know something, right? And that's how most of us prompt. So they're saying most of us prompt it in an unspecific way. That is why they're also going to add this simulated user prompt. Okay. And then lastly, they also need to prompt for image editing task. So they're using again character recognition to understand the before and the after image, and then understand what is the difference between these two images. And that's how this Z captioner is done, which is really simple. And this is one of the example that they give. So for this particular image, there's going to be tagging caption, which is just like each word separated by a comma, a short caption and a long caption. And this is for image editing, where I generally follow this instruction based, which is telling AI what do you want it to change. But you might be using this one. So they need to also add multiple level of captioning. This is what the Z captioner does. So now we have the data, we have the caption. Now let's see the training process of this model. So in terms of training process, they are going to use something called a single stream multi-model diffusion transformer. Now single stream meaning the text and the image are going to go in one stream. This they're doing so the training process happens faster, is simple, and is better aligned. In terms of the objective, they're going to use this flow matching training, which you have already seen for Qwen, C-Dream, and Flux context. If you don't know what flow matching is, so basically in the diffusion process, a noise is applied to an image, right? So image sees the before and the after, and there is a match that's happening between both of these images, the noised images and the clearer images. And this noise gets removed, of course, by the captions, but there is this matching happening between these two images. That is basically what they call as flow matching, okay? Then the text encoder is going to be Qwen 3, which we'll be using later on, and this they are using because it understands both English and Chinese. Then VAE, they're going to use the Flux VAE because it's good for encoding and decoding. Now this image encoder comes in for image editing tasks, but this is what we'll be using. And for encoding, they're going to use something called as Unified 3D ROP. Now why are they using this? This they are using because whenever it is denoising, right, it has to understand the relationship between the old image and the new image. For example, let's say it does not know the position of my nose and denoised here. So my ear is replaced by nose, my nose is replaced by ear. So this ROP is basically called as positioning embedding. RO stands for rotary. So this is rotary position embedding, and 3D because it understands the height, the width, and the resolution of the images. And this is not so important for image generation tasks, but is really useful for image editing tasks because you need to know what is the change happening. So my hand goes from here to here. Now it can't be like in between somewhere. So this is where this 3D ROP or position embedding comes in the picture, okay? And this is how the training process has been told by Z image team. It's a bit complicated. It's not really that complicated. Okay, I don't understand it entirely, but I'll tell you what I understand. So we do know this part, right? Which is the text encoder, image encoder. So all of this gets converted into tokens. Now this is for image generation. This is for image editing. So this is where your tokens are generated. Now if you don't know what tokens are, because AI cannot understand words or images, it converts most of it into numbers, right? That is called as a tokens. Now these tokens need to go in the training process. Now here they are going to use a single stream where all of these go together, right? So you see here the text and the image simultaneously go in the training process. The first step here you will see there is something called as ROP, which is position embedding, is understanding relationship. So we are putting these tokens of the noised image, also of the clear image. So understanding the positioning link is what is happening in stage 1. In the next stage, which is the FFN block, what is basically happening is there is a stable and clear information. So let's say there are some tokens in both text and images that are redundant. They're going to remove it. So basically a clean and nice data is going to follow in the training process. And lastly, you get this output projection and predicted velocity, which is basically understanding how to remove noise. So this is overall the training process, and this is happening through flow matching. Okay, so this is where one of this engine is kind of done. Now this engine is applied multiple times, and that is where we call it as pre-training. Now in pre-training, they're going to use multiple stages. The first is going to be a low resolution pre-training, where the same training process follows for 256 by 256 resolution, which is where the AI understands basic concepts of style, composition. You can imagine this as this mixture of experts model of WAN 2.2, where we had the low model and the high model, where one was done to understand the overall concept and the other added detail. So here in the pre-training process, with low resolution of 256 by 256, this understands the overall schema of the image. Then there is something going to be called a omni pre-training, where they have an arbitrary resolution from 1K to 1.5K. That is 1024 by 1024 to 1536 by 1536. That is another reason why I love to read research paper, even if I don't understand it 100%. Now I know what is the resolution at which this particular model works. So you are okay if you add resolution between 1024 and 1536. So this is what is happening in this Omni pre-training. The next stage is going to be supervised fine-tuning. Before this, let's see this diagram, which is really interesting. So this shows you the progress with each of the training processes. The first one is pre-training, then is supervised fine-tuning, then we have prompt enhancer, then we have the FSD, which is few step distillation or the turbo model, and then we have reinforced learning through human feedback. So you see at each of these stages, the image starts getting better and better. You can of course pause and read the prompt, but in the first case you see they clearly mention in the prompt, the warm lamp light catches the scene, casting a soft glow on both their faces, which are mirrored in the polished dark wood surface on the table. And while in the first two cases we don't see the lamp, the next three cases we see the lamp. But you see with the third one, the reflection is quite harsh. The fourth one, we see the reflection. I think it's a really good image, but with RLHF, there is more detail added to it. So each of this process kind of adds more detail, and at each point, the entire training process done, because that is the engine. So it has to pass through pre-training, supervised fine-tuning, prompt enhancing, then few step distillation, and then human reinforcement. So all of this again has to go through this engine that we already saw. Now let's see the stages that's happening in the supervised fine tuning. Each of this is 2 pages. I have compressed it into 3-4 words. So the first step is distribution narrowing. So here they're only going to keep the best images and remove unstable stylization or inconsistent rendered images. The next one is concept balancing. Now again, because this model is only trained on 6 billion parameters, there might be some rare concept which might not exist. So to add this, they look back at the world topological graph. If you remember, we had Wikipedia, we had like cat that goes under animal, that goes under nature. So this graph they look at and add rare concepts. And lastly, because they're adding these rare concepts separately, for example, let's say the rare concept of parametric design, which is going to be 1, 2, 3, 4, they merge all of this together. So there is at least removal of some bias. Again, each of these models do have an inherent bias, but they're trying to remove this using model merging. So this is the base Z image model done. Of course, there's going to be RLHF. But right now, let's see the next step, which is how the turbo model came into existence. So here they're saying, due to the inherent iterative nature of diffusion model, our standard SFT, which is fine-tuned model, requires approximately 100 number of function evaluations to generate high-quality samples using CFG. Now this 100 you can imagine as steps. So they need 100 steps. And right now, the turbo model is 11 GB. I can't even imagine what is the size of this full model. I'm assuming it's going to be at least 40-45 GB, which in hindsight, that is what Flux should have done. They should not have released the 64 GB model, but first released like a turbo model, and then release the full version because people are already into that ecosystem. It's just marketing, man, just marketing. Now let's see how this turbo model is trained. Now generally in a turbo model, what happens is you have this teacher-student comparison process where we already have the main model, which is the teacher model. Now what does the student do? It mimics it in lesser steps, right? Because this, it already knows what has to be done. This, the student only has to repeat it in less steps. So this is where the distillation process comes in, or the turbo model come in. So what they're saying, to do this, they're using 2 steps. One is this decoupled DMD, and the second is DMDR, which I will show you later on. And generally, they're saying the process involves using something called a distribution matching distillation. But when they used it, they had a color shifting issue and they didn't want it. So because of that, they use a decoupled DMD, which retained the image quality and had a stable training process. So when I read the paper, this is what it meant. So generally in DMD, this image quality and stable training happens simultaneously. They separate it out. So the image quality and stable training happens separately, and that's why it is called as decoupled. So if you read further, it says, in practice, decoupled DMD effectively addresses the pain point of traditional DMD, which is generally what a distillation model uses, ensuring sharp detail preservation and color fidelity. Notably, the resulting distilled model not only matched the original multi-step teacher, but even surpassed it in terms of photorealism and visual impact. So because they used this separate DMD, they were able to get higher quality model. Okay, and the next stage for this turbo model is something called as DMDR, where R stands for reinforcement learning. Now, this was really interesting to me. So what they're saying is whenever there is reinforcement learning, there is a scoring that happens to this AI images, right? Now what AI does, it kind of cheats by giving any random images. To avoid this, they are going to use this RL, where basically the model creates images that humans like, and DM creates constraint. So with this constraint, we get better images. You see how AI models are cunning as well. They also want to get their job done, okay? And they are trying to constrain it so that it doesn't do unnecessary images, but images that look good. And that is how the turbo model came into existence. And this is a nice visualization that shows adding all of these stages help to get a better turbo model. And this is what they say. Our decoupled DMD successfully resolved these artifacts. Now these artifacts are blurred textures and shifted color tones, restoring sharp details and accurate colors. Finally, Z-Image Turbo refined via combination of decoupled DMD and DMDR represent the optimal conversions of speed and quality. It achieves 8-step inference. So that is why in the case sampler, you ideally add 8 steps. That is not only indistinguishable from the 100-step teacher, but frequently surpasses it in perceived quality and aesthetic appeal. So this is how we got the turbo model. The next step is about RLHF, which is reinforcement learning with human feedback. Now the first row of images does not have human feedback. The second row of images does have human feedback, and it does look better, right? For instance, here you see this lion, only head is there. Now here in this case, the lion actually looks like it is riding the kangaroo, which is a really wild concept, but it's fine. We take it. It's a world of AI, okay? So to do this RLHF, they're using 3 stages. The first one is called reward training. Now this is similar to when we go to artificialanalysis.ai website, where we get 2 images, and depending upon what you like, you click and there is a scoring given. So this is what happens in the reward training stage. Now the next stage is called direct preference optimization. Now here this is offline. Now this offline and online is not on the internet. The offline means you already have the images and you're scoring. Online means as the images are generating, you're scoring. Okay, so that's the difference. It's not internet or no internet. So in the first stage of direct preference optimization, this is for simple tasks where to understand if the text are correct, if the object counting is correct, and it progressively increases. So maybe let's say in the first case there is 1 apple, then 5 apples, 10 apples, 15 apples, and so on and so forth. And using the vision learning model and human feedback, they see if this is correct or wrong, and again there is going to be a scoring. And for this group relative policy optimization, this happens online to check the photorealism, aesthetics, and instruction following. Now this is happening live. It is kind of similar again to the artificial analysis website, where you get multiple images immediately and you keep on scoring it, and that makes the model better and better. Okay, so this is what RLHF does, where you add humans for the scoring. So model learns what human like and it gives you better images. Okay, so this kind of concludes the training process of this model. Now for final touch, they're going to add this prompt enhancer with reasoning chain. And you might be wondering why they're adding this prompt enhancer now, which is what I wondered. So basically what they're trying to do is, because it has less understanding of the world, right? The model has very less understanding. It has only 6 billion parameters. So they're going to add a pre-trained vision language model to the model so it understands our prompt better. So this is for us. For example, if I prompt a cat in a mountain in Delhi, so it has to understand what is a cat from this overall scene of cat. It has to understand what kind of mountain, and then it has to understand, okay, Delhi means capital of India. So somewhere it has to create a scene that looks like India. So this is what prompt enhancer does. So this is what they're saying in this example. So you see in the first case, when they gave this coordinates to the image model, it kind of created any image and added the coordinates, but this is the exact coordinates of that particular location. Okay, it can't do for all of this coordinate system. It kind of is pre-trained somewhere else. Okay, or for example, a detailed process of, I'm assuming, how a tea is made, where here it kind of listed it and only made a tea. Now here it is giving you step-by-step process. So with prompt enhancer, it kind of breaks the prompt down and gives a detailed instruction of what has to be done. So this is the last step. I know there's a lot of blabbering that I have done, but I hope you understood why this model is so good. Some of the key things to remember is that it's trained on only real world images. Then you can prompt it for 1K to 1.5K, that is 1024 to 1536. Then the steps for turbo model remains 8. And then of course in the paper, in the next step is going to be this performance evaluation, which I personally don't go into because I find a little bit of bias there. I don't know. It's just me. Okay. But anyway, let's see all of the training process once again. So the first step was gathering data. So they gathered the data using filtration. They removed AI content. They clustered it to keep only the best images, remove a lot of duplicate images. Then they added world knowledge because it's only 6 billion model. They added some rare concept which they felt were not there in the model. And then human fixed some of the scoring systems. Then they added captions to all of these images using Z Captioner. The first step was using an optical character recognition which understands all of the characters in that particular image. Then they had multiple levels of captioning. The interesting one was this simulated user prompt, because according to them we prompt not so sensibly. Then for image editing, they again used OCR for before and after images and understand the difference. Then we had the training process. Now for the training process, the main engine had a flow matching training where the AI learns how to denoise seeing the original image, and that is guided by the captions. Now this machine is run multiple times to get better images from the model. The first one was low resolution training, which was 256 by 256. Then with Omni pre-training, there was ambiguous resolution from 1K to 1.5K. And then we had fine tuning to get good images and remove biases. Okay. Then the next step was the turbo model. Now for the turbo model, they got the step down from 100 to 8, which is basically done using a teacher-student relationship where the teacher is the original model and the student learns how to recreate with only 8 steps. Now to do that, they used two things. One was decoupled DMD and then DMDR, where in decoupled DMD, they kind of restored the color and the distortion that was happening. And with DMDR, using a humans as reference, they trained the model to understand what humans like. The next step was RLHF, which is reinforced learning through human feedback, where there was a reward system kind of similar to artificial analysis website where images are done and you simply click on it. Then for simple text and object counting tasks, which was done offline where all the images are already been done and they were rating it. And the next step, which was photorealism, aesthetic and instruction, that was done online, which basically means the images were created live and then tested live. And the last, for final touch, they added a prompt enhancer because it has only 6 billion, and then of course it was benchmarked. So this kind of concludes the training process. I know it's a bit exhaustive. I don't know why I went so much detail into training process on research paper of this model. Just felt like going in detail because after a long time I found a good research paper. After that, they also show you in the paper how good it is for text generation, and trust me, it is absolutely brilliant. It does not do well for vertical text, but it does really well for horizontal text. So if you are creating posters, illustration, this is the model for you. Okay. And in the conclusion, they concluded by saying whatever has been done so far. The one thing that I didn't like in this research paper is that they did not mention about limitations of the model, because each model has a limitation. And I wish they had mentioned that. Of course, I have come up with my own limitations later on, but here they clearly mention, beyond the robust base model, our pipeline yields Z-Image Turbo, which enables sub-second inference on an enterprise-grade H800 GPU and fits comfortably with 16 GB VRAM. Additionally, we developed Z-Image Edit, an editing model efficiently derived via our Omni pre-training paradigm. Through this pipeline, we provide the community with a blueprint for developing accessible, budget-friendly, yet state-of-the-art generative models. You don't need 16 GB of VRAM. There are also already GGUF models available of this. The last step is understanding the licensing of this model, because that is very important to know whether you can use this model to sell, make money, create LoRa's or not. So this particular model, similar to Qwen and Van, uses Apache 2.2, which is a really good licensing, which basically means you can use this model commercially, you can make money from it, you can make images, videos or LoRa's. The only thing you need to include is licensed copy when you make a LoRa or an app, and you cannot use the trademarks. Okay. So now that you saw the training process of the model, it is a really good model, and you saw that in the research paper as well. Now let's see what to install inside of ComfyUI. So the ComfyUI version that I am using is this 0.3.76, and if you are in the same version, you'll be able to do everything that I am doing. Okay. The first step is, let's see which is the model that we need to download. So if you go to this particular link, it has 3 folders. The first one has your diffusion model. The second has your text encoder, and third has the VAE. So if you click on each of them, and this you need to download inside your diffusion model folder. So wherever you have downloaded ComfyUI, download this 11 GB model or 12 GB model inside the diffusion model. Then you need to download the text encoder inside the text encoder folder, which is around 8 GB, and then download the VAE inside the VAE. Okay. And this is very simple workflow. So this is the workflow. And that is it. If you have more than 12 GB VRAM, you are set. You don't need to do any optimization needed. You basically add your diffusion model here, which is the 12 GB one. You add your clip model, which is 8 GB, you add VAE, and that is it. You don't even need to add a negative prompt because the CFG one. The only thing that I have added is this clear VRAM, because I've noticed on my ComfyUI when I run this multiple times, my RAM gets clogged and it does not run. So that's the only thing to add, okay? And you see it takes around 16 seconds to run this, okay? So basically you have your model, then you have your prompt. We don't need a negative prompt. You have your image size and resolution. So in this case, you can go from 1024 to 1536 because it trained from 1K to 1.5K. Then you have your K sampler and VAE. Now steps like in the paper we saw it is 8. Now sampler and scheduler, there are multiple combinations. I found Euler and simple to do fast image generation, but there are other ones also. And then this becomes your K sampler plus VAE, and this is your output. As simple as that. This is what I love about this model. It is so simple. There is no chaos. My scripts remain clean. I don't know, my OCD thanks it. And these are some of the images that I have generated, and you see how good the images look like. Look at the realism, okay? The second image, I wish the seam was little bit shifted to the right. This would look like this is real. Okay, the third image may feel like it's not realistic, but overall these 5 images look so real because the training said they have only real world data. Now the recent release of ComfyUI, the base version of the workflow is already there. So if you just go to ComfyUI, you click on template, then you see this one, Z image turbo text to image. This whatever the workflow I already showed you already exists here. Here in the ComfyUI version, they're using steps as 9 and sampler and scheduler is different. But because of this, I got around 51 seconds at generation time. So that is why I avoid using this res multi-step and rather go to Euler. If you want good images that take longer generation time, you can go with res multi-step. I am okay with those quality of the image because they are really good. Okay. So this is the model that you can use and this is the workflow. But if somebody does not have 12 GB of VRAM, I'm also going to show you how to optimize your output. Okay. So the first step is going to be steps. While the model says that you can use 8 steps, I also tested it for 4 steps, 6 steps and 8 steps, and 4 step is really unusable. You can go to 6 steps, which in my opinion is really good. On my computer it saved around 3 seconds, which is still okay. So if you compare the 6 step and the 8 step, the quality difference is very negligible. Let me show you another example of this cat. So if you see with 4 step, it is really noisy. Let me zoom in. So you see this is pretty noisy. With 6 step, it looks nice. With 8 step, of course, it's going to look exactly how you want it. But I think if you want to reduce the generation time, you can of course go with 6 step. Okay. But I'm going to stick to 8 steps because that is what the model recommends. But you can of course go with 6 steps as well. So this is with steps, and similar to other models, you do have GGUF version of this model as well. So while we had the original version of the model around 12 GB, you do have the GGUF version around 3.79 GB. So you can use this as well if you have low VRAM. Or on CivitAI website, I found an FP8 version of this particular model, which I am using, and that is around 5.74 GB. And I find this model really good. It is half the size of the original model. And if you go down on CivitAI, here they clearly say the steps between 5 to 15 works. I think 6 should be minimum, and CFG1, this will ignore negative, so no need for them. And here they also mention that if you use the other scheduler, you get better images, but it is 40% slower. And like I showed you, it does give you better images, but it is really slow. So I would not do that. So I made a quick comparison of the BF16 versus the FP8, which is the 11.5 GB and the 5.4 GB model. And this is the version that I really like. Okay, let me show you some of the tests. So on the left hand side, you will see the BF16, which is the 11 GB model. On the right hand side, you will see the FP8, which is 5 GB model. Okay, and you see, you can't really recognize it. Okay, in terms of time, yes, it is only 3 seconds on my computer because I already have 16 GB of VRAM. But I am assuming if you have, let's say, 8 GB VRAM, this will work on your computer. But you see the quality difference is really negligible, and I personally prefer this. I think I'm personally tired of my computer being tired, you know. I am tired that I have to run these exhaustive models on my computer and my computer keeps crying, getting hot. I'm absolutely tired of this. So I'm also looking for ways how to reduce capacity on my computer. Even though 12 GB will work, I will still use this because I'm done. I'm absolutely tired this entire year running my computer in the background screaming. Okay, enough of me and my computer relationship. Let's see the next example. Again, in this case, the cat example. And to be honest with you, I love the result from this. I like how both of these cats' eyes are closed. One thing that I didn't mention, that the seed of all of this is same, which is 100. I love this. It's closed. I don't know what this cat is suspicious, right? So I like the image from this. It's up to you. I like the image from this. Then in the next case, in this case, I think I would choose this 11.4 GB model just because how the origami looks nicer, but it does not look bad at all even with the 5 GB model. But it's up to you with your preference. I would still go with the 5.4 GB model. And then for exploded thali, again, both of them look really good. If I would give this as a blind test, nobody would know that this is from 11 GB versus 5 GB. And that is how good even the FP8 version of this is. So I would highly recommend using this. And this is what I will be using as well. Okay. Now, similarly, how you have GGUF model for your diffusion model, you also have GGUF model for your text encoder as well. So I'm going to test the full 7.5 GB of the model versus the 3.07 GB of the model, which is a GGUF text encoder. And you can download this from this site. So you have minimum of 2.5 GB to 4.28 GB. One thing to note before using this, you need to update the ComfyUI GGUF version, because I tried it and it did not work. Once I update it, then even the GGUF text encoder does work. Okay. And the workflow looks something like this. So the only thing you need to change is this one, clip loader GGUF model, and that is it. The entire workflow remains the same. Okay. And now let's look at the differences. So this is with the full version of 7.5 GB. This is with the 3 GB. And you see, there is hardly any difference. I don't notice it at all. It is absolutely same. You see, there's a human here, there's a human here, there's a human here, there's a human here, but it is absolutely same. So why would I give 4.5 GB extra to my VRAM when this can happen on 3 GB VRAM? And you might have noticed the time generation is same, 15 seconds, 15 seconds. But you will see the VRAM used in the first one is 92% versus 73%. Okay. I'm just trying to save my computer, nothing else. It's gone through enough this particular year. It's gone through enough. Okay. Anyway, let's see the next example. Again, really same. I would not understand even if you tell me that, okay, one is from 7.5 GB text encoder versus 3 GB text encoder. I would be like, this looks same. Okay. Now the next two example is where you will see the limitations of using a GGUF text encoder. Now, for example, here in this case, you see the birds look less origami than this birds. So basically what is happening is because it is a GGUF version of the text encoder, its understanding of text reduces. Okay. So if you want something that is super stylistic or a super elaborate long prompt, go with the 7.5 GB version. But for most, I don't know, maybe 90% of the cases, this model also works. Okay. Even for this next example, while both of them look really same, you see, the spoon does not exist here. In the first case, we have around 1, 2, 3, 4, 5, 6 cups. Here we have only 5. So this is because of the GGUF model. If you have an elaborate prompt with lot of styles, with lot of aesthetic value, then you will see some artifacts. But 90% of the cases, it does not matter. Okay. Then recently, we also had an all-in-one model. And I was like, okay, let me test it out. So this came around 2 days back, and you have two versions of it. One is a 20 GB model and the other one is like a 10 GB model. So I downloaded this, and you download this in your checkpoint folder, and the workflow looks like this. So this is kind of going back to your HD 1.5 version of the workflow, where you don't need to use again separate VAE, again a clip loader, text encoder, nothing is needed. All of this is combined in one particular workflow, and the time generation is absolutely same. Okay. And here are some of the examples of all-in-one model versus the FP8 version of the model and the GGUF version of the text encoder. This is around 8.4 GB. This is around 10 GB. But the time generation is 2 seconds less than this because everything goes at one go. Here it has to separately add to my VRAM, text encoder, diffusion model. But to be honest with you, I prefer this. I see a lot of artifacts here. For example, you see this blue thing that's happening here. I don't know what is this. I don't know what is happening here. I would personally prefer going with this, which is still less than the all-in-one version model. If you see the next example, both of them look really good. I don't know why I prefer this maybe because the cat is longer. I don't know. The cat is shorter. That's the only difference that I can notice. But I would still prefer this 8.4 GB total version versus this 10 GB of the all-in-one model. Now this, I didn't really like the output from the all-in-one model. I found a lot of discolorization happening here. It didn't look appealing to me. And then in the last case, this also looks really nice, but it has reduced the amount of cutlery that was there in the plate. Now there is no spoon and things like that. So I don't like it personally, but it's up to you. So what is the conclusion of this comparison? So this is how you can select the model. So ideally 8 steps is good, but if you are low on VRAM, you can go also with 6 steps. The best performance is going to be with both the full version, that's around 19 GB. It works on my computer. I'm just tired of my computer screaming constantly. The first option for low VRAM is you get the FP8 version from Civet AI. So that makes the total around 13.2 GB. The next version is you use the all-in-one model, which is around 10 GB. The next option is you use a GGUF version also of the text encoder. That makes around 8.7 GB, and which is what I'm using. And I have done multiple tests in the last 1 week and I'm really happy with this combination, but it's up to you. I have given you multiple combinations, so you can choose one. And if you still have a lower VRAM, you can again download a less version of the GGUF model for both the diffusion model and the text encoder. Okay, now let's see some of the workflows. That includes the base, upscaling, image to image, image masking, and ControlNet. So the custom nodes that you will need to install are these 4 custom nodes. The first one is for ControlNet. ControlNet does not work with the desktop version yet. It works on the portable version. Then you need RG3 as the image comparer. You need easy use to have that clear VRAM node, and then ComfyUI GGUF version to load the GGUF version of the model. Okay. Now the base version is, like I told you, is looks something like this, where you have the clip encoder of the GGUF version. Now this, you can also download the GGUF version like I mentioned and simply connect the prompt both to positive, negative, add whatever you want, and you get the image. As simple as that. Okay. Now let's see the upscaling workflow. And in this case, you need to download some upscaling models. So you can go to manager. From there, go to model manager inside ComfyUI. There you can type upscale, and I have downloaded these 3 models, which is Full Hardy, Ultra Sharp, and NMKD. If you want, I will link my upscaling video here, which talks in detail about how upscaling works. That is for HDXL, but the ideology remains the same. And this is the workflow. Okay. The first part of this workflow is exactly the same what we did. All you need to do is add another K sampler where the denoise is between 0.2 and 0.4. Because what denoising does is if it goes to 0, you get exactly your image. If it goes to 1, you get a new image. Now here what we want to upscale it. So we want to retain the originality of our image. That is why the denoising of 0.3 works. Now before this, you need to add the upscale model. Now why am I doing this 2 times? Now you see I have added load upscale model. Here I am using 4x Full Hardy. Then I am again saying upscale model by, and I am upscaling by 0.5. Now why I am doing this? I am doing this because the model is 4 times. Now if I do 1024 by 1024 into 4, it will become 4K resolution. It takes a lot of time. So I am dividing it by half to get 2048 by 2048. And this is a very simple workflow. Now let's see some of the examples. So this is 1K versus 2K. And I'm changing the prompts here. I was bored of those 4 prompts. So this is more like a roller coaster vintage photography. And if I zoom in, here you will start seeing more noise in the 1K, whereas in the 2K, it starts getting much, much better. So the upscaling does work. Okay, let's see the next example. Now the prompt was simple, illustration of a house in jungle. And you see how good it is. Let me zoom in. And here you see with the 1K version, I don't know what is this animal, but this now looks like a nice soft toy. And this, I don't know, maybe it's a donkey or a dog. Now I can understand it. Okay, this could be a dog. Or in the window or the wall textures, you see, this looks much better than what it was earlier. So by simple upscaling, you get really good result. I didn't tell you the time, right? So it takes around 54 seconds to upscale the image. You see here, it takes around 54 seconds. So the base one is around 19 seconds plus 54. I think totally it takes around 90 seconds to get the full image. Okay. And then in the third prompt, this was more like a cafe scene in an outside coastal region. And let me zoom in here in this case as well. And you see this floral texture on this chair doesn't look really good, but on this chair, it looks really nice. Even this particular faces in the background, I don't know what is this. This is like an alien, but this looks like it's a human. Okay. Even in this case, I don't know what's happening to her face. this looks really better. So upscaling really works, and because it is trained on real world images, you do get good outcomes. Okay. Now next, let's look at image to image, which is again a simple workflow. Basically, you add your image here and you need to say VAE encode, because you need to encode this image that goes in the latent space and is diffused. Okay. Again, of course, you need to change the denoising number. For this stage, I think 0.5 to 0.75 is a good denoising value. So these are some of the examples that I have created. The first one, from this exploded thali, I created an architecture, and you see how this bread has been converted into windows. So you understand that there is a correlation. Even this circular plate has been converted into this threshold of this house. Looks really, really nice. I find this really fun to just change the denoise value. You have your original input image and you get something really new. Okay. Now the next example, I took this building and I added that roller coaster prompt, and you see now this became like a fair, and it kept this architecture because the denoise is 0.55. If I would increase it, it would even change this architecture. I love this. I love playing with image to image. It could be any random image. You can create anything altogether. Okay. Or in the next example, here I added this cat and I wanted to create the same cafe scene, but because these flowers are so big, you see this looks like it's a miniature version of the cafe, and it kind of distorts the reality. It really looks nice. Although this cat is like, why did you do this to me? But anyway, so you can do image to image, just change the denoising value and you will be surprised by the outputs that you get. The next one is image masking, which is again the same process. Only thing here, you need to add set latent noise mask node, because when you'll be masking, it has to go through the diffusion process, right? And again, you need to change the denoising value. That is it. It's really simple. The first example is I highlighted this building and I said future is made of cotton candy. And you see now it's added this kind of it doesn't look like candy, but looks like cotton. So that's nice, but it retains the architecture. And again, the denoise is 0.65. If I would go even lower, let's say denoise of 0.3, it would retain the entirety of the architecture, but add less of this cotton effect to it. Okay. The next one is interesting. So I masked this cat and I said young husky dog lying in grass. Okay. So with the exact same pose of the cat, we get a dog. So amazing. So nice. Even you see the same light is falling on his head. Absolutely love it. You know, masking is really good. Just test it out. Then in the next case, I masked this exploded thali and said exploded Lego spaceship. And you see, looks so good. I just had this weird idea that this looks like Lego because broken pieces. So I said exploded Lego spaceship. Absolutely nice. So you can use the same workflow again, just add set latent noise mask and then change the denoise value, mask whatever you want, and you will get really good results. Okay. I know this is more like a bullet train of example that I'm showing, but we have seen all of this image generation, image to image editing by now. Okay. The next one is going to be ControlNet. Now we already have the model, which is called Z Image Turbo Fun ControlNet. It's around 3.1 GB. This you should not download in a ControlNet folder, but rather model patch folder. But this does not work in the desktop version of ComfyUI. As of yet, as of today, which is 9th December, this does not work. It does work on the portable version, but so I downloaded a portable version, tested it out, and it does work. And this is the workflow that you will need. So you need to load your image. Then you need to use AIO aux preprocessor, which has all the control nets. If some control nets are missing, let's say for instance, when you use depth for first time, it will download it. So don't worry if it's taking time. And then I get the canny map. Now the GGUF text encoder and the clip remains the same, but instead of using apply control net, you need to use this Qwen image diff synth control net. So this is what you need. And for that, you need to use that model patch. That is why the ControlNet goes in the model patch folder, not in the ControlNet folder. Okay. The model remains the same. Now here you can adjust the strength value, how much ever you want. And here I'm simply saying elevation of a crowd and organic residence made of steel and mountains. And you see, I get those cat ears to the building. Okay. In this case, don't change the denoise because it will go back to your input image. Keep the denoise to 1, rather play with the strength of this ControlNet. Okay. Even in the portable version, this might not work in the first attempt. It did not work for me. What you need to do in the portable version, you need to update your ComfyUI, not inside, but through the update folder. Okay. So this is where your portable version is, right? So in this case, you go to ComfyUI portable, and then you get this folders. In this case, you need to go to this update folder. From there, you need to click on update ComfyUI.bat. Okay. Double click on this file, something will run and you will get this kind of a long text. Once this is done, it will say successfully installed ComfyUI front-end package 1.33.10. Once you do this, then the ControlNet of ZImage Turbo works. If you don't do this, it might not work. It did not work in my case, but once I did this, it did work. Okay. And this is the workflow, like I already showed you, the same workflow. And some of the tests that I did. So I uploaded this cat image, converted into architecture, and you see the cat ears look like this building. It's really fun. It's the same ControlNet, we used for SDXL, Flux, and now you're using it for ZImage. Okay. In this case, I also used a depth map. So you can also combine this. So what you can do is you can add another one. So you can simply copy this, paste it, the model goes to the model, and to that you can add a depth preprocessor. That's also fine. Okay. So I'm adding Canny plus depth, and this is the output that I get. In the next stage, I added this exploded thali, gave this cafe outdoor scene, and you see how this fabric is now taken the shape of this plate. The people are sitting inside. Even this cup that was floating has now become this flower basket. Absolutely love it. The next one is also really nice. So I took this roller coaster image and I converted it into Christmas tree. Christmas is nearby, year end is nearby, year is getting over. I don't know what to do. I feel scared and excited at the same time. But anyway, some other time we talk about year end. So I converted into a Christmas tree, and you see this roller coaster shape has been converted into this lights, and then there is a star on top, and the entire Christmas tree is kind of cascaded inside of this metal structure. It looks nice. Of course, the humans look really bad. That's one drawback of ControlNet, right? Because it's taking inference from the input image. But of course, if you upscale, it will get better. So this is how you can use ControlNet with ZImage Turbo. And there are some other tests that I have done. The first one is going to be text. And this blew my mind. It really will blow your mind. Just hold your chairs or whatever you're sitting. And this is the prompt. And you see, this is the output. I have not altered this at all. So I just wanted to create a poster. So the first one, the title is subscribe. You see, subscribe. Then there is going to be ZImage Turbo. I suddenly realized why the title of this poster subscribe is that to remind you, please subscribe. I see a lot of people watching the video but not subscribing. To get this number up. Then I said ZImage Turbo text testing. And you see ZImage Turbo. I did like how it separated the text and testing, like giving more space for the word. Then there is geometry in design, generative AI studies, digital fabrication 2025, metallic forms, all of the word exactly as it is. Then K Darundari, KU_DS, architect and designer, again, as it is. Okay, then volume 12, issue 1, global architecture, December 2025 edition. Again, how good is this? Okay, of course, these numbers are really gone, but you can simply mask this. No, this is, again, it takes around 1 minute to make this. It's really blew my mind. That's why I think even though the other model, which is the Ovis model that came up by Alibaba, it's really good for text. I think this is enough. I am happy with this one model. I think I'm going to shift from Qwen to this now. If we get good editing models and LoRa's, done. We are going to shift to ZImage Turbo. The next example is this interior scene. Again, look at the fonts. It does so well, so good. I have no words. This can really go as production, if you upscale it, this can really go as production, but looks really nice. I mean, you can pause read the entire prompt. Now, the one drawback of text is that it doesn't do vertical text correctly. For instance, I do love this. I want to sleep right now. And you can specify the font as well. Like sleep like never before, ultra soft comfort technology. Somebody making an ad, please, you can hire me. But here you see I mentioned here vertically and then vertical here. So it tried to write the font vertical, but it did not. So one of the drawback of this model, I mean, it's not a drawback, it's too much of expectation from humans, is that it cannot do vertical font correctly. It can do anything horizontal. You see, Cloud Nest Pillow Company, done. World's softest pillow, done. Absolutely correct. Only thing it can't do is vertical text. So please keep that in mind whenever you're using text. Now the next test is for style. So I added the same roller coaster font, added different styles to it. So watercolor, Lego, paper craft, porcelain stained glass, claymation, futuristic neon. And I personally wanted to see this because it's a small 6 billion parameter model to know if it can do this major styles. Of course, niche styles it can't do. You can train a LoRa on it, but it does really well. Then I tested it for lighting. So the same cat, and you see one was for light and shadow, volumetric lighting, neon, golden hour, moonlight, candlelight. I don't know why it convert orange cat into tabby cat for moonlight and candlelight. Maybe it's a training set, but all of them look good. And then you can also change the palettes as well. So in the first, the cafe beach scene, I said a metallic kind of situation, a stone theme, food theme, and you see all of these look food, like this dress is made of noodles. And then you can also change the time, the season. It's more like autumn, it's a rainbow, grayscale. So it does work for most of the thing. 90% of the thing that you want to generate can be done by this model. Okay, I'm not lying. It does really well. Okay, now let's see how to do this inside of ComfyUI. Okay, so I have opened ComfyUI. It's a quick tutorial. All of the workflows are already there in the presentation, but I do know some people like a tutorial, so they can work along with me. So I'm just going to make a 5-10 minute quick tutorial on how to work Z image inside of ComfyUI. So the first thing is we need to double click and we say diffusion model. It says load diffusion model, this one. Then I will take the FP8 version. Then we take K-sampler. In this case, we add our model to model. Then we need to add clip text encode. So this becomes both my positive and negative prompt. Then I will add clip GUF version. A clip loader GUF is fine. In this case, I will select this one. In this case, you can either select Lumina 2 or you can select Quen. Both are fine. Let's say Lumina 2. Now we need to change this. So steps remain 8, CFG remains 1, Euler simple is fine. Then next step is so we add empty latent image. In this case, we make this as 1024 by 1024. Really simple. Connect it to the latent image. Then we need to decode it. So we say VAE decode. So we connect the latent to samples. Then we need to select the VAE. So I can select load VAE. And this is going to be a simple flux AE. And then from here, I will say clear VRAM, because like I told you, my VRAM keeps clogging when I use this particular model. And then we can either say preview image or you can say save image. Either way is fine, and you can specify what you want to name it as. Okay, and then simply just add a prompt. I'm going to add the Christmas prompt because Christmas is nearing, and I will run this and let's see the result. So this is the prompt that I added. It was more like Christmas trees in a snowy urban city at night, and of course we can read the prompt. And this is the result, and I absolutely love it. Okay, in terms of time, this did take around 32 seconds, and I have noticed when I'm recording videos, because there are multiple things happening on my computer, it takes at least 30-40% extra than what it has to take. But now if I don't change the prompt and just change this seed value, let's say I make it 256, and if I make it fixed and run this, you will see the variation will be very less. Now with the same prompt, I made 256 as a seed, and this took around 29 seconds. But you see, it's kind of the same image. Let me take both. So you see, this one was the first one. This one is the next one. You see, the overall composition does not really change, and that's one of the drawback of ZImage Turbo, is the variations are not really seen. I would have liked to see different street or something else, but the variations can't be seen. Okay, now the same thing, let's see how we upscale it. It's really simple. What I will do is I will remove this save image. So we just need to copy the K-sampler, and that is it. Now what we need to do, our same model goes to model. Then here in this case, denoise need to be between 0.2 or 0.4. I will keep it as 0.3. Then the latent is not there yet. We need to make all of this. So we can copy the positive and the negative prompt. So the prompt remains the same. I'm going to copy it. Of course, you can keep the scripts clean later on. And then we need to upscale this. So first I say upscale image using model. So this is the image that I want to upscale. And the model that I want to use is, you can use anyone. Let's say we make NMKD SciX. In this case, I like Full Hardy and NMKD SciX both. But now in this case, like I told you in the presentation, this is going to upscale 4 times. So we need to reduce it. So what we say upscale image by, and then we make this as 0.5. And in all of this, the most recent one is Lanczos. So this is going to be half. Now we need to encode this. So we say VAE encode. So this is what gets encoded because that is the size. And now we need to use this same VAE, and this goes to the latent. Once that goes to the latent, again we need to decode it. It needs to convert back into pixel resolution. Then the same VAE. Now here I will use this clear VRAM, and then this is it. And now I'm also going to use image comparer. You will be annoyed with the way my workflow is, but that's why in the presentation I made it much nicer. So let me compare the A with the B. Okay, and this one I will save. Just in case if I'm feeling a little bit later on Christmas FOMO, I can use this image. And now I will run this. And while it is running, I will try to clean the script, is what I love. If anybody has a job of cleaning scripts for maybe ComfyUI, Grasshopper, don't hesitate to call me. Now let's see the result. Let me zoom into the image comparer. So this is the before and this is the after. And you see this, I don't know what this thing was. Now it looks like a face. I love how the fur is getting better. See this? It looks nice when you upscaled it. The tree has more details. Even these shop lamps look really now like they are hanging lamps and not just like ice balls. So it looks really nice when you upscale it. I do know you can use different methods of upscaling. There is like SeedVR2 and things like that. I did test it. I still prefer this version because we are using the same model, which is the Z Image Turbo. And I generally like if you are using the same model as an upscaler, it looks really good. So you see this is the 1024 version and this is the upscaled version. And you see a lot more details get added to it. So if you're going to upscale, I would recommend you to do this method. If you want more details, you can always change this to res multi-step as the sampler. Scheduler you can keep the same, but the image generation time will vary. Okay, it will be much slower. So this is how you can create the base image, upscale. Now let's see how you can quickly image edit it. So what I will do, I will first take load image. I'm going to take the same Christmas image. Why not? Now in this case, I don't want to upscale it. What I want to do is I'm going to copy this part of the prompt or the script rather. Now in this case, we need to use this image as the latent. So we remove this. We take our VAE encode here because we need to encode this image. Similarly, how we did for upscaling, right? And then we need to VAE decode this. So we use the same VAE and then I will say save this image. Okay. In this case, we need to change the denoising value. So I'll make it like 0.5 or something and I will bypass this. So I will control B this because otherwise that will also run, and I need to add clear VRAM here. And now we need to change the prompt. Okay, just made a random prompt. Street view of a residence on Mars with brown dust and robots. The house is made of robotic parts. I don't know how this is going to look because this is no correlation, but let's see. Okay, let's see what it generated. So this was the input and this is the output. Okay, this is not great. So what did it retain? It retained the lamp, it retained the house, it retained the position, it retained these humans, but added robots. And right now I'm using a denoiser of 0.65. If I increase it further, that will go to my prompt. So let's increase it. Okay, let's see. I did 0.7 first, but it gave a very bad output. So I make it 0.66. Yeah, I think it does work. It doesn't feel like it's Mars, but yeah, it does work. There's a lot of robots and I do like these robots. But anyway, you understand with image to image, just add the image. Maybe not that wacky as a concept, as a prompt, but you will get it. And now for the same image, I can mask it. So right click, say open in mask editor and mask whatever you want. So I will increase this thickness and size and make it circle. So what do I mask? Okay, I think I will mask here itself. Should I convert these humans into robots? Well, that's a good thing to do now. Okay, let me save this. And right now, we need to also use set latent noise mask. So your mask goes here, your latent goes to samples, and this latent now goes to your K-sampler latent. Okay, as simple as that. And now prompt whatever you want. So I'm just going to say robots walking on the street. And again, you need to add a denoise value, otherwise it will become completely different. Because I want to maintain the structure of the people walking, I will keep some denoise value. Okay, and let's run this. Okay, let's see the result. Yeah, it added some robots. It did not convert all of these into robots. But where are the heads? The robot has no heads. Oh no, I guess I had to mask more. But anyway, you understand the concept. You can mask anything. Let me open in mask editor. Maybe I should have masked more. I guess let's mask the entire thing. And then I will make another version of this. Okay, let's see this result. Oh, this looks much better, right? There are two robots. I wish they were different, but yeah. I guess somewhere in the world there will be robots walking on the streets in Christmas, right? I like this. I like how the reflection is being carry forwarded and it looks good. I wish all of them would be converted into robots, but I guess that's fine. That's how you get with the masking, right? If I would increase the masking, then it would be really chaotic. Let's try one more. Let's try one more with 0.85. No, doesn't work. So 0.75 was a good number. I mean, you have to mask more again further, but this is still making all of them as robots, but they don't have heads. Dang it, AI, dang it. But anyway, now this is with 0.8 and we have all the robots. There are no humans, but robots don't have heads, but it does work. And what is good is that it looks realistic. It does not look like this robot is AI. And this is not upscaled. This is 1024 by 1024. You can always upscale it using this particular method. Now for the ControlNet one, it does not work with the desktop version. You need to load the portable version. So I'm going to close the desktop version, open the portable version quickly and show you how to do the ControlNet version as well. So I've opened the ComfyUI portable version now. Only for this reason, I downloaded both. Anyway, it's the same workflow. Like I showed you in my presentation, it's exact same workflow. I'm just going to change this image. I'm going to take the same Christmas image. I don't know if I'm making another video until next year, so why not be in the Christmas theme? Now here we have Canny, but we can use any other ControlNet. I'm using Canny because it's good. Strength, I can keep it as 0.75, and I'll keep the same elevation of a curved and organic residence made of steel in mountains, and then I will run this. And like I said, for this, keep the denoise as 1, otherwise it will go back to your input image. Okay, let's see the result. And it's going to be literal translation of this. So whatever these humans were walking became this kind of arch, tree remains same, and we have the architecture here. Now this is because the strength is a bit too much. If I make it like, let's say 0.60 or 0.55 and then run again. Now again, what it has done, it's understood this humans as something to make an arch. It's put tree here because there was this tree kind of silhouette, and this is the architecture. Doesn't look really good. What we can also do is we can combine two control nets. Let me show you how. So this is the workflow which combines both your canny and depth. So what you do, you take two AIO aux preprocessor. In one you can use any depth map, then you can specify the separate strength for this. Now in this case I'm going to keep the strength as 0.5 for canny and the depth as 0.3. I'll copy the same prompt here and then we will run this. Okay, let's see the result. And it takes both canny and depth, but there's a lot of canny. You see these lines that have come here. Those lines are from canny ControlNet. So we need to reduce the canny, and I think the depth is working fine. So you just need to reduce the canny right now. And I think the prompt can be different. So I can make this as 0.45 and something similar would be nice. The prompt. Okay, I'm just saying Christmas with robots on Mars. It's absolutely ridiculous, but fine. But it takes time. It takes time to find this correct strength value for both of these to get a good image. Not just for this one, but any controller that you use, it takes a lot of time to find the correct value for both of these. Okay, let's see this. The controller has become too much. The Christmas tree is same as it is. The people have been converted into, I don't know, this kind of robots, but the ControlNet strength has become too much. Now what I'll do, I'll keep both 0.4 and 0.4, and then this is the last step. Okay, let's see this. Yeah, you see these lines that are there. Those have come from canny. The strength has become too much, but the Christmas tree is nice. The robots looks nice. No, not 100% there yet, but we need to keep playing with these values of ControlNet and you will get good result. Okay, but anyway, this is how you can use ControlNet. Right now the drawback is ControlNet is not available for desktop version of ComfyUI. I would recommend you to wait for some days. Don't download the portable version like I did because I had to show it for the video. Just wait for a few more days. You will get the ControlNet for desktop version. It is this particular node which is model patch loader. It is not taking the ControlNet for Z image. They have to update it. Once they update it in desktop version, you will be able to make it. But this is the workflow that you will use. This is when you combine two control nets, and this is when you have a single control net. Okay, now let's jump back to the presentation. I will show you some of the limitations and conclude this long video on Z Image Turbo. Okay, but now let's see some of the limitations of this model. And the first limitations is variations. It does not create a lot of variations no matter what seed you use. For instance, you see the roller coaster in all of these scenes is same. The profile of the geometry is same. Okay, there is minute change in this bulb, in the way that is added the artifacts. Overall, it is same. And this I feel is a real drawback because I like to get multiple iterations of a design as an architect. There are certain nodes inside of ComfyUI we can change the variation of the image, but built in it does not exist. Or in this case of cat, okay, the cat's position is changing, but I guess there is also good in this. Let's say you want to create variations of a certain character for a film. This would help. You can just change the seed value, but the character won't change. But for architecture and design, this is a little bit of a drawback. The next one is knowledge, right? Because it does not have the entire understanding of the world knowledge. I found this one example where if you add an exploded view, where basically you're showing the interior of the spaces, the walls are not there. This does not do a good job. I compared it with Fluxmania and Midjourney. Of course, Fluxmania is trying to do something, but this is really bad. It's just like, I don't know what it is, but this is another limitation because it does not have a good world knowledge understanding. So if there are any niche things, you're not going to get it. Okay, just keep that in mind. You might as well go to Midjourney for it, or some stylistic thing that you want, go with Midjourney. On the second example, I just said old Indian house interior, and I don't know what is this. This does not look like an old Indian house interior. This looks really bad. This looks like somewhere there was a storm or something like that. This looks nice. It is not 100% Indian. There's a mix of European in this, but I guess it's fine. And Midjourney does a good job. Point of this is that it has a limited world knowledge. So please be careful the way you are prompting. If it is really niche, you will not get good result. Okay. But these are the only two limitations that I found. One was the variations and one was world knowledge. Okay. So what is the conclusion of this? I am really happy with this model. I am absolutely happy with this model. Both me and my computer are happy with this model. My computer is like, I can use only 80% of my VRAM. I am happy. I am happy with fast generation. We both are happy. It is a really good model for photorealistic images because it is only trained on real world data. It is simple, minimal. It's a no fuss model. There's no much multiple wiring creating chaos in ComfyUI. I absolutely hate it. Okay, it's good for LoRa training. I've seen multiple videos. It's good for LoRa training as well. It's a fun model after a long time. I felt like the last fun model that I used was that had less of technicality. I think Van was fun, but it had a lot of this like mixture of export, low noise, high noise, nonsense. I would say was Fluxmania. It is the most simplest model, not like Fluxmania. After that, I think this has to be the most simplest model. Now I'm just waiting for style transfer to be added and image editing capabilities. Okay, if these two things are added, I think we will have the full suite of Z Image Turbo. Now some of the things to note when you're prompting is I have noticed be as descriptive as possible. The more descriptive you are, the better it does, because if you remember in the training process, they add a prompt enhancer, so it will enhance your prompt. So be more descriptive in your prompt, you will get better images. Okay, then like I said, vertical text is not possible, and then there is limited knowledge. Okay, it's only 6 billion parameters, so please keep that in mind. But it is a really fun model. I would really suggest you all to use it. I think this has to be the most fun release of the year in terms of AI. But that's it. That is my detailed deep dive of Z Image Turbo. We looked at everything from training process, text to image to image masking, image editing, ControlNet. Everything was done in this particular video. It's more like a total guide on Z Image Turbo. And if there are any further models released, I'll make a video on this because I really like this model. In the meantime, please do like, share and subscribe the video. Helps me to create better content, and I'll see you in the next one. Thank you.